All right, so you should remember this from Honors Chem, PV equals nRT. And what we're doing today is really simple, except that the questions that they ask you are just a little bit more challenging. So let's just go through each of these. If you're given atmospheres for your pressure unit, then it needs to match your R value. So look here for your R. That's how you know which R value to use. Your volume's in liters, but be careful, they may give it to you in milliliters, which means that you need to convert. And there's 1,000 milliliters in 1 liter. Your number of moles is obviously moles. Your R values are the tricky ones. So I'm just going to point these out to you. Let me grab a new sheet. Because now you're going to start seeing more of these R values, and you've been using consistently 8.314 unless you're Dorian, who uses 0.08206. But 8.314, look at the units. It's joules per mole Kelvin. And then 0.08206 is liters times atmospheres mole Kelvin. And then this one is so infrequently used because most of the time even I will just convert my torr to atmospheres just so that I could use the one that I'm more familiar with. But you could easily use this. So you're checking your pressure units here are for your gas laws. And then over here, this is for thermo, right? You're not going to use this number when we're doing gas laws. So you're going to check that your atmospheres match your R value. And then temperature, obviously, they can give this to you in degrees Celsius, so you're going to need to convert that. So the equation PV equals nRT is on your equation sheet, so you don't necessarily have to memorize it, but make sure that you pay attention to the details. All right, so we're just going to solve problems primarily for the rest of class. It says a 8.65 liter tank contains helium gas at 16.9 atmospheres and 25 degrees C. How many moles of helium are available for making balloons? So you literally go to the dollar store, you're going to blow up some balloons. Here are the conditions of the tank, and now solve for how many moles of gas are in the tank. So which equation will you use? PV equals nRT. Why are you not going to use P1, V1, P2, V2, that one? Okay, so there's moles and there's just one scenario, right? If you're given two situations, then you need to use the P1, V1, P2, V2. But this is obviously including moles in only one scenario. So go ahead and set this up and solve. So the answer is 5.9 moles. Now let's pretend you take those 5.9 moles and you go and use those moles to fill 1.5 liter red balloons. Different than the last slide, right? The situation there was that you had, I think it was 8.5 liters, now you're at 1.5. And you were at a much, much higher pressure in the last question, and now you're at 0.99 atmospheres, and then the temperature went up. All right, so you have a new scenario, but the same number of moles of molecules, of gas. How many balloons will you end up with? So there's a few approaches here. So I'm just going to let you sort of think about what you want to do first. What do you need to know? Like, it's like me saying I have 50 cookies and I'm going to give 5 in a bag. I'm going to put 5 in a bag. So how many bags can I get? 10. What did you do? You took the total and you divided it by the part, right, to figure out how many bags. So if you want to fill up these little red balloons, you know that each of these little red balloons is 1.5 liters. What could you do? Divide what? Because this is a different scenario. The 8.5 liters here contain that whole tank of gas for those moles. And then your 1.5 liters, it's just they're at different scenarios. If they were the same temperature and pressure, you could do that. But they're at different temperature and different pressure, yeah? Right, that's one approach. So what he said is that you could take your moles here and put them in the new scenario and find how many liters the new scenario would. Like, think about this. Look how pressurized that is. Your next scenario says it's 0.99 atmospheres, like 1 atmosphere. So if it has high pressure, here's high pressure, what would happen to the volume if you're at low pressure? Does the volume go like this or does it go like this? It increases, right? So obviously our volume must be getting bigger because we went to such a low pressure in the next scenario, which means that we must have a much larger volume of the balloon, not the initial 8.5 liters. The volume's expanded quite a bit, so we can fill a lot of these 1.5 liters. So you could either use liters to do that, but the other approach would be to use what? What did you solve for here? These are the moles that you have. So if you figure out this scenario, you can figure out how many moles would fill each of these individual balloons, right? And then you could divide 5.9 by the individual moles. So you're either going to take total volume and divide by little volume, or take total moles and divide by little moles, and then you'll figure out how many balloons you can fill up. Can you handle it? You can. So if you want, step 1, PV equals nRT using your moles in the last problem. Solve for volume. So rearrange your equation. So V equals nRT divided by P, and use your 5.9 moles here. And then plug in the information that you've just been given in this problem. That's your total volume. And then divide by your small volume. You can. If you would have found moles, right, you could have definitely did it differently. We'll just get to all the same final answer. But just, this is not using sig figs. It should be 150 here. And then you divide by your 1.5 liters, right? So how many balloons? 2? 100. 100 balloons, right? Or if you accidentally use the 149, then you would get 99 balloons. Does that make sense? These problems aren't usually very hard. It's that either you need to know the approach for them, or it's just this higher order thinking. Like, this is not so chemistry related, is it? It uses a little bit of chem in there with the gas laws, but then it's just thinking about, like, what do you need to find? All right, next problem. This one says, an unknown gas is collected in an 850 milliliter vessel at 1.02 atmospheres and 23 degrees C. So I'm hopeful that if you are taking the free response section, you would recognize you need to use gas laws at this point. How do you know?
Pressure, volume.
They give you pressure, they give you temperature, and they give you volume. You've learned nothing else in chem yet that includes all three of those, right? Like, we don't do equilibrium with that, and like, it's just obvious that this is a gas laws problem. It says the evacuated vessel has a mass of that, and then the vessel and the gas have a combined mass of that. So what does evacuated mean? Empty, right? Cleaned out, there's nothing in there. So if that's the weight of the container, and then you put something in the container, then you just subtract the two weights, and what do you get? The mass of the gas, right? So it asks you to find molar mass. So this is just the approach you have to just memorize. Anytime the AP exam asks you for molar mass, it is really just asking you, do you know what the units of molar mass are? And can you solve for them? What are the units for molar mass? Grams per mole. So if you could, and they have to be for the same substance. You can't have grams for one substance and moles for another. It has to be for the same substance. So do you have grams in this problem of the gas? Anywhere can you find grams? Yeah, right? You just subtract these two and you would get grams of the gas. Do you have a way of finding moles of that same gas? Yeah, because they gave you PV equals nRT information. So all you're going to do is come up with each piece and then divide grams by moles, and you would come up with a molar mass. They most often do this as a multiple choice question. It's pretty easy to do. So go ahead and try that. So you needed to first convert milliliters to liters. You can use the same pressure, and then you needed to convert 23 plus 273, right? 0.0357. 3 sig figs there. So that's fine if you didn't. And then you take this, take your moles, and you divide, you take your grams and divide by your moles. So what was your grams? Yeah, you have to subtract them. And then you subtract and divide by 0.0357. What did you say?
46.
I'm so sorry. I told him no, that's the wrong answer. In my mind, I was thinking the next problem is 80, and I was thinking it was that one. You, however, Where was your mistake? Oh, you went 850,000.
Yeah.
Right? And honestly, that's a simple mistake. Like, I even do that sometimes. I have to physically tell myself to remember which way to go. So if you have 850, I will sometimes say, if this is milliliters, I'll just tell myself, all right, 1,000 milliliters equals 1 liter, and then I'll remind myself that this would be down here, and then I just go the other way. I mean, I almost sometimes set up the dimensional analysis in my head, just to confirm. All right, anybody need help with this one? So grams divided by moles. All right, this next equation is intense. So I'm going to show you something just because I want to expose it to you. I want you to recognize that you're able to derive equations. Like, you're all very smart, right? And you just need someone to expose you to something, and then you're like, okay, and you've learned it, right? For the most part. If you've never seen anything or you haven't worked with it, then there's a good chance you're just not going to be able to do it. So I'm going to show you how to derive equations. You're not going to have to derive it on the exam, the AP exam. Certainly if you forget the equation because you didn't memorize it correctly or something, then maybe you would have to derive it. But I think this is just useful as you're like moving through college and you're probably going to go into some bigger fields where you're going to use equations, whether it's in chem or math or finance. You may need to derive an equation. So what does deriving really mean? You're solving.
If you're given an equation, then like you're solving for like solving for a variable in that equation.
Give me more. Because if you're solving for a variable, you could do that using algebra. When you're deriving something, what are you doing? Yeah? Manipulating it by putting equations where? Like an equation from one source.
Making it equal to one thing.
Yeah. You're taking pieces and like plugging them in to make a new equation. Like, I'm sure you guys have been like, how did they come up with this? Well, because they probably just put a bunch of pieces together of information that they had, and now they have this new equation that they use. So derived equations are very easy to come up with, especially if you know the sources of them. So I'm going to show you how to derive this equation. The question says, an unknown gaseous hydrocarbon has a density of that at 1 atmosphere and 28 degrees C. Find its molar mass. So we know molar mass is grams over moles. We also know that this is sort of like a gas laws problem. So I'm going to write the equations out for you. Just follow along, right? Some of you will hate it, and you'll be like, I don't even care that she just did that. But some of you will appreciate that you can do more than you think. So the first one that we have is PV equals nRT. We know that we have density. So density is what? What's the equation for density? Mass over volume, right? What is the mass and the volume typically given as?
Mass and gram.
Like, look over there. What is it? Grams and liters, right? If it's not, then obviously it would be like milligrams or liters. But because they gave us grams and liters, those are the units that we're going to use. What is the equation for molar mass? We just did it. Units. Grams over mole. Right? All these equations that we know. But we want to come up with one equation that tells me what molar mass is. So I'm going to derive an equation to come up with that. So look at your main equation here. What variable in there is somewhere in the other equations? N, okay? What is N? Moles. This piece matches this piece. Give me another one. Volume, right? This piece matches this piece. So let me rearrange this equation such that it gives me just moles. So moles is equal to grams over molar mass. And I'm going to rearrange this equation, volume, is equal to mass, which is in grams, divided by density. And this was in liters. Agreed? All right, so now I'm going to rewrite the equation. I'm going to move my recording. And I'm going to start plugging them in there. So P is equal to volume here, which is mass over density. And then what am I writing here? Grams per molar mass times RT. Following? But I want molar mass to be by itself. So what do I need to do next? I need to do some algebra to move it around, right? So if I want molar mass by itself, I multiply it on both sides, right? I'm going to rewrite it for you so you can see it. MM times P times mass over density and that's in grams, is equal to RT GRT, correct? Now what? What should I do? I need molar mass to be by itself. Something. Divide by P. Okay, that's easy to do. Divide by P. Now what do I do with this? Technically, right, you divide by it, but then you flip it. Right? Like if I need to divide by this, just do it. Mass divided by density, and then I'm going to divide by mass divided by density on this side. When you have a fraction in the denominator, you multiply by the reciprocal. Look, I'm running out of space here. All right, so now I'm going to multiply by the reciprocal, so D comes over mass, and this cancels out. Okay, so I'm going to rewrite it again. I'm going to move this all the way over here. I think we've got some space. All right, and so this is going to say molar mass equals, what I have here is grams RTD over P mass, which is in grams. What can I cancel? My grams, right? And what I'm left with is MM is equal to RT times D divided by P, and that's your equation. And that's exactly what we need. We need to find molar mass using density and pressure and temperature, and we have R. So, yes, that's challenging, and who wants to do that on an exam? No one. But can you? If you have pieces of information, you can certainly come up with it. So instead of us deriving it, I gave you a little format to memorize it. What is that? Look at your slide. Yeah, it's pretty awful, but you're going to remember it. So all cats cover their pee with dirt. So watch. Right? All cats, what do cats say? Meow. Meow, meow. All cats cover their pee with dirt. DRT, dirt. RTD, same thing, I just rearranged the letters, right? Meow meow covers his pee with dirt. All right, we're going to say it all together. Ready? Yeah, you are. Then we're going to say it over and over until you say it. Ready? Meow meow covers their pee with dirt. Meow meow covers their pee with dirt. Are you not saying it? Now you have to say it alone. Go ahead, Lou. Now you have to say it alone. I didn't hear it. I'm sorry. What was it? Because I didn't hear it. Yeah. How many of you have cats? What do? They go in their litter box. It's disgusting. And they pee, and then they like shove all of the litter all over. I don't have a cat. I am not a cat person. But it makes sense, right? That's what cats do. That's how you remember it. You don't derive it. You just say molar mass is equal to DRT over P. Meow meow covers their pee with dirt. Now you solve. Okay? So solve the problem. The density has to be given to you in grams per liter, but I've never seen them not give it to you in grams per liter, so you should be fine with that. All right, so let's solve. Next part, right there. All right, so it should be 80.1. So you just plug it all in. I have not seen them give you a density in which the grams is not given. But say, for example, it were 3.24 milligrams per liter. Remember when you have two units, like a numerator-denominator unit, write it like a numerator-denominator. And then if you were to get this and need to convert it to grams, well, now you just do 1,000 milligrams is to 1 gram, and your milligrams would cancel, and you would be left with grams over liters. So you can change your units very easily just using dimensional analysis. Just make sure that you don't write them side by side. They're actually numerator and denominator units, okay? I haven't seen them do that, though. Just be cautious. All right, last question. A lot of times they will give you one substance and ask you to find out information about another substance. This is honors chem. What did you do when I gave you moles of A and I asked you for grams of B? You used dimensional analysis, specifically stoichiometry, right? Same scenario. What volume of CO2 can be produced when 68 grams of methanol burns in air at blank and blank. So I'm asking you for substance B's volume, but I'm giving you substance A's grams, right? So same scenario, you're just going to use dimensional analysis, except when we use dimensional analysis and we want to get to volume, you can only use 22.4 liters when it's at STP conditions. Is this STP conditions? Slightly off, why? 1.02. If it were at STP conditions, then all I would do is go from grams to moles, moles to moles, moles to 22.4 liters. But because it's not at STP conditions, I have to use PV equals nRT. So the first thing you're going to do is find out how many moles of this there are, and then you can convert to moles of the CO2, and then you can do PV equals nRT. Does that make sense? Okay, so set that up. So you just do simple stoichiometry, and you get to your moles of your CO2. So now you're just going to plug that into PV equals nRT, and you'll solve. $50 liters. Okay. So you're just going to finish your homework, and I gave you the answers earlier so that you can check them. And we're going to do some multiple choice practice problems.